SN1? No, not SN, addition, subtraction, AS1. Yeah. He's the only one that should have popped up on today's.
It didn't pop up for me, that was the only thing. It had a 2012 date on mine. I can go back and look.
Anybody have a question about any of the items on it? We're okay? As how are we coming with the addition of and subtraction of numbers and other bases? If you did the concrete, built your little rod of however many long. If it's base 6, it's a rod of 6. If it's a flat of what? 36. If you built those and did it, pretty easy, isn't it, to make those exchanges, just like we did when we had the beads. We skipped the base 4 blocks and went right to the counters. But we actually had our place value chart as we were moving them to make those exchanges. Did you make that connection between what we had done and where we were going? Anybody want to ask about any of the addition or subtraction?
Can we go over the instructional algorithms for different bases? Because for some reason I understood everything else but that, and I don't know why my brain just couldn't comprehend it.
Do you want me to make one up, or do you want to give me a problem?
You can make one up.
Okay.
I don't really have a problem in mind.
Let's do the addition problem 2, 4, 3 in base 5, and let's add 3, 3 in base 5. Who'd like to come and do this with the instructional algorithm? Nobody's feeling real comfortable. Katie?
This comes from, you have 6 of these and you have to borrow one of these, so that adds 5 to the 6. So you get 11. And then you're going to do it for this one. Oh wait, this is adding. Oh. Okay, sorry. I think it's subtraction. Okay, gotta get my mind on addition. Okay.
Start on the left for me, would you?
On the left? Okay. And then this one and 1. Okay, so what you do is these add up to, oh, I messed up, sorry. So that adds up to 5, so that is actually a 0. So you put a 1 over here because it's 1 unit of the next one. So then 0 here, and then 0 all the way across. And then this one, you have 7, so you have 1, 5, and 2 left over. And then here you have 6, so you have 5, which is 1 unit here and 1 left over. And so then this is wrong.
Is that right? She caught her own errors. And it's easy to do because if you forget which base you're in, right? You, okay? Did that help?
Yeah, a lot.
Can you show us one like that that's subtracting instead?
Okay. Let's do 4, 2, 1. Subtract 1, 3, 3. Who wants that one? Okay.
Can I just do it standard because I like doing standard? I find it easier. That's what I do.
Go ahead and do it standard, and then we'll see if we can get somebody to come up and do it.
Okay. Is it okay?
Because they really tie together.
Right.
Yeah.
Is it okay if we change the base to 10 and then change it back to 5? Because I find that a lot easier.
Did everybody hear the question?
I don't know why. I just can't.
So turn that base 5 to base 10, then add the base 10s, or excuse me, subtract the base 10 numbers, and then
The answer turn
then
back
turn
into
the
base
answer
5.
back into base 5. That would accomplish, it would get us the answer in base 5, right? But it's not going to get us to the thinking that we need. So I'm not going to allow you to do that on an exam. Now, you can check your answer that way on the exam. But I need to know that you understand the procedure. Okay, talk out loud here.
Okay.
You got stuff going through your head. So start over and just...
Okay, so because this was less than 3, I took away the 2 and made that into 1. But because the 2 equals 5 units, I added 5 to that 1, which made it 6. So subtracting 3 from 6 makes it 3. And now because I can't really subtract 3 from 1, I'm having to take this 4 and turn it into a 3. And then I have
What is she really doing here? Huh? Exchanging. She said one of these is worth 5 of those. So she made an exchange. Okay, the word your teacher probably used was borrow. We want to get rid of that word because we're never going to give it back. We're just going to keep it over there. Okay, we're going to make an exchange. Technically, we're going to make an equivalent exchange. If you're going to make an exchange, it better be equivalent. Otherwise, it messes everything up. So one of these is equivalent to 5 of these, so we're going to take one of those and what are you going to...
Yeah. So, because... So this is... you kind of got me confused there now that you started talking.
Sorry.
Okay, so because I changed that, this is 5 squared, so that makes it 25. Adding to the 1, it makes it 26. Subtracting 3 from 26 makes it 23.
But that really isn't a 3. If you're going to call that 26, that's really not a 3.
Yeah,
What is it?
it's... I think it...
31?
Brianna, I'm very comfortable just waiting, but if you get uncomfortable, let us know and we'll pitch in and help you. But,
This is-
but I don't want to pitch in and get in the way of your thinking, so. It is really difficult when you're up in front of everybody, right? And the pressure's on, but I just, something tells me she knows what's going on, so I'm gonna try and let her do it, rather than jump in and bail her out. Can we do this? Rewrite the problem off to the right and start over,
Sorry,
Okay.
I'm getting myself in beat.
okay? Okay, talk out loud. Let us know what's going on inside your head.
Okay, so 1 can't be subtracted by 3. So you cross out the 2, make that into 1. And then because 2 is equal to 5, you add 5 to the 1, which makes it 6. So 6 minus 3 would be 3. And then you can't subtract.
And tell me, what is that 1 up there that you got?
That's basically what the 2, that's basically like equal to 1 rod.
Okay,
So,
1 rod. Okay,
and then, because I can't subtract 1 rod from 3 rods.
you mean 3 rods from 1 rod.
Yeah, 3 rods. I have to exchange again, making that into 3. And since that is 5 squared, and I have
It's how many rods?
25.
Huh?
25,
25 rods?
yeah.
Here's our unit, right? Here's our rod, and it's got, let's see, got too many. There's 5 of those, right? And then over here is the, okay, so we had 4 flats. Now we've got 3 flats because I came over and got 1 flat.
To exchange.
So what are you going to do with that 1 flat that you just got?
I'm gonna add it to my rod,
Okay,
which is gonna make it 30 in value.
how many rods did you have before you went over to do your exchange?
1.
And what did you get when you went over to get it, to
That's
make the exchange?
5.
5 rods, so you now
That's
have
where I messed up, okay. So.
6 rods.
Which makes that 3. And then 3 minus 1 flat is 2.
Okay? She was trying to take everything to the ones, turn it into a 1 rather than keep it in the place value that it had. Thank you. All right. The instructional algorithm with this number. Anybody want to come and try that? Melissa?
Is that word?
Okay, so we can't take the 3 from the 1, so we just borrow from here, and I just do the +5. So it'd just be 6 minus 133. And then I can't take the 3 from the 1 again, so we just borrow from this again, and I just put +5. So it'll be 5, 6, 6. And then it's just Did I do that right?
Everybody follow it?
Okay. So every one, so every bar, so like a rod, just think of this as the rod places. So every rod is worth 5 of the of the little cubes. So that's where I get the 5. So when you bring one rod over, it equals the 5 little cube things. And so you have to add that to the 1 because you already have the 1. So that's where I get the 6, and then I just bring down these numbers. And then every time you borrow like a block thing, it's got 5 rods in it. So that's where the 5 rods come from. And you already have the 1, so that equals the 6, and then you just bring down the other numbers. Does that make a little more sense?
So that's 6 rods.
So yeah, this is 6 rods. Because a block equals 5 rods. And so if you borrow a block, it's equal to 5, and
If
you
you
already have.
exchange.
If you exchange a block and you already have the rod, you add it to it. Does that make sense? More sense?
I would also allow you to do it this way. This is thinking about it in the base 10, because there's really no such thing as a 6 in base 5. So you could do it this way. I don't have enough to take the 3 from the 1. So I'm going to come over, and this becomes 1. I'm going to exchange one of those for what? 5 of these, and I already have 1, so that makes 6 of them. 1 group of 5 and 1 6. Does that make sense? Yeah.
I think that really helps me since it's Monopoly, because you make the houses and then you can turn it into a hotel.
Oh, how many houses does it take for a hotel? It's been a while since I played Monopoly.
3.
Huh?
4.
Who's played most recently?
I don't know, but like that's
But that's the exchange, yes. And it's not 10, I know that.
no, yeah.
So it's some other base that you're actually exchanging houses for hotels. Yeah, that's a good way to think about it. So I had, let's just say that in Monopoly you can exchange 5 houses for a hotel, since we're in base 5. So what happens is I can't take 3 houses away from one house. So I come over here and borrow a hotel. I exchange a hotel for 5, that's 6 houses, which is 1 hotel and 1 house. You see how? Okay? So I'm ready to subtract here, but now I go to subtract and I can't do that one. So I come over and exchange one of these, and I don't, now the Monopoly thing doesn't break down because the hotel's not worth 5 of something else, but you can get the idea. And so now I've got, and I'm ready to subtract, but when you, this is the pure base 5, I'm keeping these numbers in, that's really 6, right? 1 group of 5 and 1. So now I'm taking 6 minus 3 is 3, 6 minus 3 is 3, and 3 minus 2 is, or 3 minus 1 is 2. I think it's fine to write it this way if you'd like. And yeah, you don't really have to do that when you are adding, but okay. Anybody else? You'll get more comfortable with it. We'll do more and more of these, including today. All right. What I need everybody to do is look that way while I write a problem over here on the board. So I don't want you watching me write it. As soon as I get done writing it and I say go, I'd like everyone to turn this way, and I would like you to do the problem as quickly as you can. No calculators. Do the problem as quickly as you can and just yell out the answer to see, who can get it the first. Okay, look that way. Don't watch me write. Go. Too slow.
219.
Way too slow. Tricia, how did you get it?
I just added up like 2 numbers at a time.
Like this one plus this one? You're really fast then at adding. She got it really quick then. You were right there with her. This is interesting. I've never had this happen before in a class this size. Someone would have gotten it in a fourth the time or less. How?
Because if you add the 43, like there's 2 sets of 100, so if you do 43 and 57, then 62 and 38, and then the 19 is just left over.
You didn't holler it
That's
out.
how I did it, and I had it before her. But
Oh, come on.
Well,
Well, that renews my faith. That, you know, there's. Did everybody see her method? Is that easier than going? Let's see. That's 105 plus 19. That's especially if you're trying to do it mentally. And if you're you can do this mentally the way you did it, like that, right? To do the other mentally and trying to carry all those numbers in your head is almost impossible. It's not impossible, but it's hard. There's just too many numbers, right? You get cognitive overload. So, why can we do that? Does anybody know?
I think for me, like the way I saw it was 3 and 7 is 10, so it had to be, and then I saw like 2 and 8, and I was like, oh, that's 10.
And why do we like tens?
Because it's really easy to add.
They add a lot easier, don't they? So if we can put them together in groups of 10, okay? So that's kind of the idea of why this is easier. Now, what principles make this so that we can do that? Does anybody know? What does commutative mean?
Just basically means with addition you can rearrange it.
You can change the order. Okay? So, I could, if I wanted to, say this is the same as 43 plus 57 plus 62 plus 38 plus 19. Right? The commutative property says I can rearrange them. Then, I can do this. What's that called? Associative property, which says I can group them in any order I want. I don't have to go this plus this and then take that and add that. I can group them. Okay, so the commutative and associative properties allow us to do that. Okay? Is that a skill you should know? Yes. Is that a skill you should teach to your students? Yes. Don't start off with 2-digit numbers. Start off with 1-digit numbers and have them make nice tens. Put the numbers to go together nicely with tens, and that will help. Okay. So, how do you teach kids the commutative and associative properties? Anybody? What might you do to help them understand those? Let's see if you can. If you'll notice on the Cuisenaire rods, pass those down, pass those down. You and your partner work together. You'll notice in these Cuisenaire rods that the white ones are of what length?